Today we will first talk about the project. I know many of you have been waiting for the project because can't wait to get started. Let's see. After we discuss the project, then we're going to, if we have time, we're going to continue practice testing. So this project, the main purpose is to give you the ability to apply what we discussed in the class to actually test a program of moderate size. Okay. To put what we discussed together, to test the real life program. The program you are going to test is a Java program. Okay. It implements a string tokenizer. Can you take like compiler class, program languages? Program languages. Does it mention the concept of token? Okay, very good. That's what that's going to help you to understand what the program tries to do. So token is basically the smallest entity that is meaningful to the compiler. So compiler, when it tries to parse your program, it considers your, for example, your program is a string of tokens. Okay, so we will first recognize tokens in your program, and then try to put those tokens into kind of a syntactic structure so that the parser can check whether the program is syntactically correct. Okay, but we're going to see examples. Okay, but anyway, tokens are the basic elements. Okay, that are processed by the compiler. And the program has about 500 lines of code, a little bit less than 500. I think it's 490 something lines of code. And including the comments, so the real code is less than 500 lines of code. And we put 15 faults in the program. And your job is to apply what we discussed in the class. Actually, the reason why I talk about the project now is that in this project you only apply control flow testing. Okay, so we already finished the control flow testing. So you are ready to get started on the project. So we have 15 faults, and your job is to try to find those faults, and by using what we discussed, mainly control flow testing. So project team. Okay. What I have been thinking about this. Okay. So there are advantages and disadvantages of making it an individual project or a team project. Right? The advantage of having a teammate is that you have someone to talk to, right? This is a significant, more significant effort than like a homework assignment. Okay, so that's what I like about making the team project by 2 members. But this part is not that big. I don't think you need more than 2 members. Okay, on the team. On the other hand, we did have every time we do have some issues. Okay, when we have like a team, sometimes the other member just does not contribute. Okay, does not meet, does not deliver. Okay, and this class is not about project management. So I do not want to put too much effort on like in terms of how you collaborate with other people. So from that perspective, I guess if you prefer to work by yourself, that's fine with me. Okay. If you want to work with another fellow student on the project, that is fine with me as well. Okay, it's your choice. Okay, if you know someone that you feel comfortable with, okay, you can set up a 2-member team. Okay, if you feel confident about yourself, you can do it by yourself. Okay. However, I'm going to have the same expectation, okay, requirements, okay, no matter you're working by yourself or you're working with a fellow student, okay. So if you really do not want to work, because I encourage you guys to work with like other people, because I do believe sometimes the different perspectives can really help you to learn on the project. Okay, but if you really do not want to work with other people, you feel confident about yourself, that's fine. The only catch is that you have to deliver the same amount of work if you decide to work with. Would that be okay? I kind of gave you a choice. If you do have a teammate, okay, then in the final report, you have to clearly specify the contributions made by each member. What each member was responsible for, what did each member accomplish. And I'm not going to get into any disputes that may happen on the project. If you decide to have a teammate, you're going to resolve, okay, whatever disputes, okay, that will arise, okay, between you guys, and we're not, because it's just difficult, okay. Like in my other class, sometimes I teach software engineering, when I work with other people is an important part of the class as well. And in those classes, in that class, we have team projects, but typically we have more than 2 members, okay, because of the size of the project. And typically I will make it an odd number, okay, if you have disputes, you guys are going to vote to kick out whoever does not contribute to the project, and you have to take meeting minutes as well. Okay, every time, every week you have to meet. But I don't want to do that for this class because the project is not that significant. It's not that big in terms of amount of effort, and we're not doing that for 2 members. It's difficult when you only have 2 members, right? It's very difficult for us to decide what is going on, right? You don't have a majority. So that's why I want to make it clear, okay? If you decide to work with a teammate, okay, you want to make sure you feel comfortable with each other. You want to make sure everyone is making the commitment, okay, to work on the project. If you do not feel comfortable, you can work by yourself, okay? And because we are not going to resolve any disputes, we're going to give the same, just give one grade. I think that's going to reduce any possible competition as well, right? We want you guys to work together, not trying to compete with each other. And then nonetheless, you have to continue specified contributions. But we're not going to, for the record, I guess it's more for the record, who did what, okay? But we're only going to give like one team grade for the project. Any questions on this, on the project teams? I think I'm going to probably give put a date by which you have to form your team. So that we know like how many teams we have. Let's see. How about the week after spring break? I know you guys are busy midterm. Okay. So maybe the Thursday after the spring break. Okay, so which I believe would be 7, 14, and 21st. I believe it's 21st.
Oh yeah, 14th is spring break, yes.
Okay, 21st. Okay, so by March 21st, you have to send an email. How do you want to do that? You just send an email to our team, okay, about the team, okay, whether you're going to work by yourself or you're going to team up with someone else. Would that be reasonable? By midnight, okay? You have to send, you can send it earlier, okay? You don't have to wait. If you already set up your team, you already make the decision. You just let us know. We also, I don't know, I believe we can send an email to the class, right? Can you, on Canvas, can you do that? If you really want to find your teammate, okay, you can probably send the email to the class, okay, on Canvas, or you could talk to our TA, maybe our TA can help you to team up with someone else who is also looking for a teammate. Okay. Any questions about the project team? Any suggestions? I'm kind of open to any suggestions. My only purpose is to make the project a meaningful experience for you, a learning experience. Okay. Any questions on the team? And we're going to discuss more details about, technical details about what the project is about, what kind of materials.
The date is the same day. We didn't send the email to the TA. It's the same day the due date or project.
No. I'm going to talk. The due date will be by the last day of class. They're going to have more time.
Oh.
It's not going to be a 1 week project. So, some information about the program that you are going to test. Okay. The input taken by the program is basically because there are 2 ways to use the program. One is that you provide the location of a file. Okay, so basically, as you can imagine, the file could be for example, a Java file. Okay, just a text file. Okay, have strings, and which this program is going to process to recognize tokens in the file that you provide. It's going to be classified. You can recognize and classify the tokens. Yes.
It's going to be available in Canvas.
Yeah, actually, I already put the program and also the. Oh, maybe I didn't make it visible to you guys. Okay, let me do that now. You don't see it right now, right? Okay. I already put on Canvas, but probably I forgot to publish. So you have it here, the project. Okay. I guess I need to click this button. You can check that.
Yeah.
Okay. Okay. Sorry about that. So either you provide a file, or if you do not provide a file, okay, then you can provide the input on the console, okay, like just like you just type on the command prompt. So that's two ways to use the program, the input. Then the program is going to process like the input you provide and try to identify the different types of tokens that may appear in the input file, in the input that you provide. Okay. So these are the different types of tokens: keyword, okay, special symbols like those parentheses, identifier, numbers, string, character, comment, and arrow, which would be anything else. If you have taken program languages, I hope this kind of tokens make sense to you. Okay. I have some examples here. So for example, if the input, if you just put this into a file and then provide the location of the file to the program is going to process this what you have in this file, and the output would be it's going to recognize and would be a keyword, okay, and then this is a code is a special symbol. It's called bytecode. So that's a token. And you have another AND keyword. And you have an identifier J. And you have this one does not belong to any token, any token type listed there is error. It's not a valid. So that's basically what this program does. So you provide a text file. The program is going to process the text file to identify all the tokens. And that's what the parser does. Okay, you can provide a Java program, like variable would be identified, right? Class would be a keyword, right? So and numbers and strings. So that's basically what this program does. And then we have the source code. So we also have the comments inside the source code. You can get more information about what this program is supposed to do. And you can compile the program, as I mentioned. Anything you are not sure, you can do experiments, right? You just try some, provide some inputs and see what the output. And this is a real program that we take from a repository that the community has built for testing purpose, so that we evaluate the effectiveness of different testing techniques. That's one of the programs behind the deposit. So what you need to do, okay? First you need to create a control flow graph for each method in your program. In the program has quite some methods. Then for each method, you want to create a control flow graph. I just want to mention that you only need to do that for a method that has at least one branch. Okay, if a program does not, if a method like a get method, you don't have to create the control flow graph. Okay, yes, there's no control structure, real control structure. Then you want to come up with test cases, okay, for each of those methods. Well, I think actually the team who worked for this class last time came up with these slides. So by selecting methods, basically means the methods that have at least one branching structure. You only need to do what we have here for those methods. Okay. You want to create test cases to achieve edge coverage, including the main method. Okay. Then you want to use JUnit to implement and execute the test cases that you have created. Okay. Then you are going to provide code coverage report. Okay, and we're going to actually to make it easier for us to evaluate. We're going to ask you to use one of the coverage was called Jacoco. That is available in Eclipse or like the NetBeans. You can use one of those IDEs you should be able to get the coverage tool. So you have to run the coverage tool to show, okay, what coverage you have achieved, the branch coverage and the line coverage, the statement coverage. For all the methods, in addition to the main method, you're going to have actually two types of coverage reports. One is for the main method is special, okay? Because the main method is the entry point of the entire program. So what happens is that when you try to test the main method, you cannot fully try to execute like all the branches in the main method. Okay, you have to measure the entire the coverage of the entire program. You have to say how many, like all the branches that you have, how many branches you cover. Okay, so the main method. For methods that are not the main method, you only need to show the coverage of the particular method that you are trying to test. So it's kind of unit testing. The main method is more like end-to-end test is the entire program, test the entire program. Okay? So unit testing individual method is more like unit testing. Okay? So even for the main method, you can still use JUnit, right? It's just the unit is bigger than other methods. Does it make sense? It is still, you can still test the, basically you test the entire program like testing the main method. And in the program you have a total of 80 methods. Okay. Yeah, I guess the team was very specific. These 3 methods you do not have to do. I believe because these methods do not have a branch structure. So you don't have to test these methods. And the catch block in Java you have like a catch block. You have an exception. You do not have to test the catch block to make it easy they do not deal with the exceptions. Deliverables. So the final report, okay, will be due basically in the last day of class. And the May 2nd is the last day of class at midnight. And the final report will have these components. They have very specific instructions and percentages, okay, in terms of how we evaluate the project. So you have to include the control flow graphs, okay, basically in the same format that we have seen in the class. You have to identify the basic blocks, and you have to show the graph, okay, that is built on top of those basic blocks. You have to include the test data for each test case you generate, okay, and also you have to show like for each test case what branches you actually cover, so the correspondence between the test cases and the branches that you cover. And you have to submit the JUnit code, okay? That basically automatically execute the test cases that we generate. We have to include the code coverage reports using JCoco, okay? There are different coverage tools that we can find. I think JCoco is a pretty popular one. It should be pretty easy for you to learn how to use it. And you also have to identify the bugs that you have detected using your test cases, and also how would you make corrections or fix those bugs, the changes you have to make. And also, we want you to have a summary about the project, some discussion in terms of like what you have learned from this project, okay, what we experienced, anything that you want to share. Yeah. So kind of like a reflection. I want you to go at the end of the project, or I want you to look back, okay, to, for example, what would you do different, right, if you're doing your similar project like this. Any lessons then, anything that you want to share in terms of your experience. You also need to include a README file, okay, to tell us how to execute your JUnit code. Yeah, and then the team will actually run the JUnit code when it evaluates the project. So I think these files are like kind of basically correspond to what we just said, the media components you have behind the final report. But we are very specific. Our previous team actually did a good job, and it's very specific about the names of the files that we are going to submit. So that's it's kind of easier for it to do the evaluation. Okay. So you rename your files like this. Okay. So everyone when you submit, you need to have those these files correspond to the components we discussed that you have to include in the final reports. Okay. For the evaluation part, okay, I think the important point to keep in mind is that we cannot only look at like how many faults you find and how much coverage you have achieved. What we have probably pay more attention to is the process you follow to detect those faults and achieve the coverage. So it's just like what I mentioned, like the homework problem, like for the IPO problem, you have to show the intermediate steps. You have to show the process, okay, the thought process. Okay. If you actually apply what we discussed in the class, okay, if you actually achieve edge coverage, and you should detect at least 10 bugs, 10 out of 15, right? The total is 15. Okay. So this is just to give you like a kind of guideline to check your result. If you cannot detect even 10, probably want to double check what you do. And you want to focus on the correctness of the contextual graphs that you create and the test cases that you are supposed to that you create to achieve edge coverage and the implementation of JUnit test cases. I think the point we is trying to make here is that we're going to probably put more focus when it comes to evaluation on like what we did, okay? The intermediate steps instead of only looking at like how many faults you find. Because from a certain perspective, like some faults you could probably find without even going through the process, right? Without actually applying what we discussed, okay, in the class. But that's not what we really, that's the purpose of this project, okay? So you have to, you want to, you want to pay more attention to, in terms of how you actually apply the techniques that we discussed in the class. Recommendations, I guess, in terms of the IDE that you want to use. Eclipse, I think it's a very popular one. How do you use Eclipse? Not that many. What do you use for IDE? Like when you write on the next one, Netflix. How many of you use Netflix? Okay, that's good. Okay, looks like almost everyone has used one of the two. And then you use Codecademy. I believe Netflix also has you can also install the coverage tool Jacoco Netflix. So let's just use those IDEs. I think it's easier for our QA to evaluate. Otherwise, it's going to take more effort to set up the execution environment.
Plus, here in general, we anti-IDE.
Oh, okay. I see. Yeah. Yeah, I know. Actually,
Most things have to compile and run on Omega, so.
okay. I see. Yeah. Do you guys? I guess for this project, you could probably do it on your laptop. You would have to use Omega, right? Yeah, I hope that's easy. I understand.
I highly doubt Omega has JUnit.
Right. Yeah. So probably you would have to use